All right, we're going to hit the highlights for Unit 8, Lesson 4, and I'm going to start on page 470. First of all, weather forecasting is simply the analysis of scientific data to predict future weather conditions. What data gets analyzed? Well, precipitation, humidity, and dew point, those two things are related. Pressure, air pressure, and then seasonal wind speeds, and seasonal wind direction, that kind of thing. Clouds, all of those things are looked at to make a weather forecast. Okay, so elements of the weather. The study of weather and Earth's atmosphere is called meteorology, and scientists who study meteorology are called meteorologists. Those are the guys that are making forecasts on the evening news, but there are a whole lot of other meteorologists that, aren't part of a TV crew. All right. Elements of weather that are observed so that we can analyze them and make predictions about weather. Air temperature, humidity, wind direction, wind speed, clouds, precipitation, atmospheric pressure, and visibility. How easy it is to see through the air, basically. Okay? All right, you can write down the answer to number 5 if you wish. Forest fighters need accurate and detailed weather forecasts. What weather elements would these firefighters be most interested in? They probably really need to pay attention to wind speed and wind direction. Clouds and precipitation is nice, but unless you have some sort of torrential downpour, you're not probably going to have enough water falling to control the fire. So they really need to know wind speed and direction to see where the fire is likely to go. All right, head down to... that stuff you don't need to worry about. Head down to the next page, and that's going to be page 474. We're going to skip all the way to 474. Let's talk about station models. A station model is a set of meteorological symbols that represent the weather at a particular observing station. All right? Station models are often shown on weather maps, but they're not shown on the type of weather maps that the general public sees. They're shown on the weather maps that are more detailed that meteorologists, for instance, would look at. Okay? You don't need to worry about answering 14 and 15 for right now, but I do want you to come down here and take a very good look at all of these symbols, because this is what we're talking about. This is a station model. So if we were going to work at the National Weather Service Center, for instance, in Austin, and we were going to record data and send all of that information to other meteorologists, we're going to do that in an area that's as small as possible. So we need to have a system to where we can convey a lot of information without very much writing, because all of this stuff has to be displayed on a map. And if we have lots and lots and lots of words, everything's going to get jumbled up, because everybody else from all the other cities, all of their information has to be dumped onto the map too. All right, so we're going to start with a circle, and that circle is going to go on our location. So the Austin Reporting Center, for instance, is going to have a circle over the Austin area. Inside the circle, we're going to color it according to how much cloud cover there is. So we're going to leave it white if it's clear outside, meaning if there's no clouds. Okay? You very rarely will see something like this, but maybe a quarter of the sky covered with clouds. Partly cloudy would be about half and half. Mostly cloudy would be about 3/4. Overcast, which means completely cloudy, you're going to color it in completely. Okay? So this is going to be colored in depending on the amount of cloud cover. So that's where we start. The next thing that we're going to do is we're going to draw a stick off of our circle. And that stick is going to point into the wind. Okay? So if we drew it here, that's pointing into the wind, which means the wind, therefore, is coming from the east into the Austin station. Okay? If we drew it up here, it would mean that the wind was coming from the north, etc. Then we're going to draw these little feathers, these little flags, off of our line, and those are going to tell us the wind speed. And the wind speed they actually give in knots, and remember that knots are nautical miles. They're not exactly the same as a normal mile that we think of. But, you know, you guys are 8th graders. We're just going to call it good. I will probably say miles per hour instead of knots, even though that's not perfect. So if the wind is only blowing at about 5 knots, we're just going to put a little half feather. If it's blowing 10 knots, we're going to put 1 full feather. 15 knots, a full feather and a half feather. 20 knots, 30 knots. If it's blowing 50 knots, then we put a little triangular flag. If the wind is not blowing at all, then we just draw a circle outside of our station circle, okay? And we'll say that the winds are calm. Then there's a designated spot for our air temperature. And honestly, most of the station models that you're going to see on weather maps here in the United States, they're actually not going to use Celsius, they're going to use Fahrenheit. So the temperature that you're going to see on National Weather Service maps are going to be in Fahrenheit. So the temperature is going to go here, kind of at the 10:30 or so position if you're thinking of like where a clock would be, or kind of the northwest position or upper left, whatever. Okay? In the lower left, you have dew point. And again, dew point is going to be given in Fahrenheit, usually in the United States, and not Celsius. Dew point gives you an idea of how much water vapor there is in the air, because if dew point temperature is really close to the air temperature, then the air outside is already holding almost as much water vapor as it can. Okay? If there's a large difference between these two numbers, then it's not very humid. Okay, so dew point compared to the air temperature kind of gives us an idea of how much humidity there is. Okay, it's not included on this particular station model, but I did put a little star here because on a lot of the maps that you'll see, they do put air pressure in the upper right-hand corner. So you need to put a little star and just remind yourself that that is the location for air pressure. All right, we're going to move along to page, let's see, this is 475, it looks like. Okay, 475, surface weather maps. First of all, you need to know that air pressure is shown on a weather map by something called isobars. Isobars are lines that connect points of equal air pressure and are marked in units called millibars. We've talked a little bit about millibars just because we've talked about hurricanes, and we've talked about the fact that a hurricane is a low pressure center, and so its millibar reading is considerably lower than normal atmospheric pressure. Okay, go ahead and write in over here that normal air pressure, normal atmospheric pressure, at sea level is about 1,013 millibars. It can vary a little bit, but that's the average. Okay? Normal air pressures are going to range somewhere between 950 and 1049. So they're going to be, you know, give or take 40 or so from this number. Okay? It's not going to vary a whole lot. Okay? All right, back up here. Isobars form closed loops. Like, for instance, here's an isobar. Here's another one. Here's another one, okay? And you guys, if you have done your unit on topographic maps, you'll see lines that are very similar to that represent different elevations. Well, here it's not representing different elevations, it's representing different air pressures. Okay, but for instance, so this line indicates like a really low area because there's an L in the middle. Okay, you go back out to this line, the pressure is a little bit higher. Go out to this line, it's a little higher, a little higher, a little higher. And you keep going higher and higher and higher until you get to this final line that's a loop, and you notice that there's a H, a high pressure area here. Okay? All right, but anyway, normal air pressure, make a note of that. Okay, typical air pressure. All right, scrolling down. What type of front has recently passed through this area? Okay, well, we need to talk about what fronts are. The image over here is kind of small, although I hope you guys can see it. Let me see if I can enlarge it a little bit. There we go. H's stand for areas of high pressure. L's stand for areas of low pressure. Generally, high pressure is associated with clear skies, nice weather. Low pressures are more commonly associated with kind of rain or cloudy weather. Okay. A cold front is going to be marked with a blue line with blue triangles. And the triangle tips are going to point in the direction that the cold front is moving. So for instance, here, this on the map is a cold front, and this cold front is moving this way, meaning that back here there's cold air, and up here is warmer air compared to the air behind it. So this colder air is doing the moving. That's why it's a cold front. Okay. Way over here is a warm front, meaning that this air behind the front is warmer than this air in front of it. And so it's moving this way, the little humps this time on a warm front, but they still point kind of in the direction of movement. Okay? So what type of front has recently passed through this area? Through this area, well, a cold front has recently passed through. What are the white lines on the map? We've talked about those. Those are isobars. They're lines that connect areas that have the same pressure, air pressure. Okay, scrolling down a little bit more. I drew these and enlarged them just so you can see a little bit better what I'm talking about. A warm front is going to be a red line with red humps. And for instance, if I draw it like this, it's moving whichever way the humps are. So if the humps are on this side, then it's moving this way. Okay? If the humps were on the other side, well, then it would be moving down. A cold front, blue triangles. Again, the triangles are on the side of the movement. So since they're on this side, the cold front is moving this way. Okay? And it just means a front is just a boundary line. Okay? That's all it is. And it's just a boundary line between two different masses of air. You have maybe some colder air on one side and some warmer air on the other side of that boundary. If it's the cold air that's doing the moving in, well, then it's a cold front. And if it's the warm air that's doing the moving, then it's a warm front. Well, what if you have a boundary line and neither air mass is moving? Well, then you have a stationary front, okay? And the blue tips, for instance, in this example, are pointed this way, which means this up here is colder, and it would move this way if it started moving. The red humps are this way, meaning that if the warm air started moving, it would be moving this way. So obviously the warm air is here and the cooler air is up here. But that's a stationary front. Stationary means it's not moving. Okay. Okay, so we're going to use several of these icons to help us figure out what's going on weather-wise in a couple of different locations in the next screencast. So you'll use these, and you will also use some of this information from your station models, so you'll need to have both of those handy.